Hey everyone, welcome back to Math Hub by Mr. H, where we make math fun and easy. In this video, we're going to be diving into the world of trigonometric ratios, the secret behind how we measure angles and sides in triangles. If you've ever wondered how engineers, pilots, and even video game designers use triangles, you have to stick around. Alright, so what are trigonometric ratios? Well, they are just comparisons between the sides of a right angle triangle. These ratios help us find missing angles and sides using three magic words. These are the sine, cosine, and the tangent. Alright, so let's break it down with a simple mnemonic to remember them. Have you heard about SOH CAH TOA? Does it ring a bell? Alright, so you don't have to worry because we will go through each of them. We have here a right angle triangle on top. So each side is labeled A with B and C. A and B are what we call the legs. And the side that's labeled C is always the longest side, which is opposite the right angle. And the longest side is what we call the hypotenuse. And you also need to remember here, this angle right here, which is labeled theta, because that will be our reference angle. So what I mentioned earlier was about the mnemonic, so SOH CAH TOA. Alright, so to find sine theta, we need to use the formula sine theta equals opposite divided by the hypotenuse. So in this case, since the angle that's labeled theta here, so the opposite to that is this side, which is marked as B, divided by the hypotenuse, which is C. So we move on to the next one. We have cosine theta. So that's the second mnemonic. So CAH stands for cosine equals adjacent over the hypotenuse. So from the given triangle here, to find the cosine theta, we need to use adjacent, the side adjacent to it, which is A, divided by the hypotenuse, which is C. And for the third mnemonic, we have TOA. That means tangent equals opposite divided by adjacent. So to find tangent theta, we have opposite, which is the B, divided by adjacent, which is A. Now, these three magic words, so we have the sine, cosine, and tangent. Also, they have their reciprocal. For sine, we have cosecant. For cosine, we have secant. And for tangent, we have cotangent. Cosecant theta, we just simply get the reciprocal of sine theta. Alright, so if sine theta is equal to opposite divided by the hypotenuse, definitely for cosecant, we just simply get the reciprocal of hypotenuse divided by opposite. Or it's going to be C divided by B if we're going to be using this triangle up here. And for secant theta, it will be hypotenuse divided by adjacent, or will be C divided by A. And for cotangent theta, so it's going to be adjacent divided by the opposite, which is A divided by B. So you have to remember all these because we will be using the concept in answering one example. All right, so to understand this further, let's have an example. Use the figure below to find the 6 trigonometric ratios. So as you can see here, we were given a right angle triangle in which the two sides are given. So you can see here that this leg measures 10, while the hypotenuse is measured 15. And here is the theta. And if you notice the right triangle, so we're missing the length of another leg, which is this one. And in order for us to identify the 6 trigonometric ratios, we need to be able to find the length of this leg first. And with that, we need to apply the concept of Pythagorean Theorem. Alright, so if you haven't watched the previous videos about Pythagorean Theorem, you can check out the link below in the description box if you want to revise for this concept. Alright, so going back, Pythagorean Theorem is going to be used to find the length of this side. So we have c squared equals a squared plus b squared. And for this problem, since the hypotenuse is given and we're missing one leg measurement, so we will be using c squared minus a squared equals b squared. So c is the hypotenuse and a is the leg, which is 10. Okay, so we just simply plug in the given measurement. So for c, it will be 15 squared minus 10 squared equals b squared. All right, and then we simplify. So it's going to be a square root of 15 squared minus 10 squared is equal to b. And 15 squared is 225 minus 10 squared is 100 equals b. And we simplify, so 225 minus 100 is 125 equals b. So from here, if we're going to simplify square root of 125, it's going to give us 5 square root of 5. Right? So that means that this side right here, so it's 5 square root of 5. All right, so after finding the measure of the leg, we can definitely proceed with or identifying the 6 trigonometric ratios. All right, so for sine theta, we know that to find sine theta, we need to use the opposite divided by the hypotenuse. So for this specific triangle, so opposite is 10 divided by hypotenuse is 15, which will give us 10 over 15 needs to be reduced, and it's going to be 2 over 3. So next, we'll have cosine theta equal to adjacent divided by hypotenuse. So adjacent is 5 square root of 5 divided by hypotenuse, which is 15. And from here we simplify. So it's going to be square root of 5 divided by 3. And that is the value of cosine theta. So for the tangent theta, so tangent theta will be equal to opposite divided by adjacent. So opposite is 10 divided by adjacent, which is 5 square root of 5. So if we're gonna simplify this, so 10 divided by 5 square root of 5 is gonna give us 2 over square root of 5. However, this is not the most simplified answer yet, so we need to do one more step. So we need to multiply by square root of 5 divided by square root of 5. So rationalizing. The numerator will be 2 times square root of 5 is 2 square root of 5 divided by square root of 5 times square root of 5 is square root of 25, which is 5. And that is the simplest form. So usually we need to do rationalizing here because we don't really leave a denominator that has a radical sign because that can be simplified. After identifying these three, definitely you'll be able to identify quicker the reciprocal. So for cosecant theta, what we need to do is to just simply get the reciprocal of sine theta. So if sine theta is 2 over 3, then we just flip the numerator and the denominator. So for cosecant theta, it will be 3 over 2. And for secant theta, okay, let me erase this part right here. Secant theta is the reciprocal of cosine theta. So if cosine theta is square root of 5 over 3, definitely for secant theta, it will be 3 divided by square root of 5. But for this, we need to rationalize it to get the simplest form. So we need to multiply this by square root of 5 over, or divided by square root of 5, which is 3 square root of 5 over 5. So that is for the secant theta. So cotangent theta equals reciprocal of tangent theta. So if tangent theta is 2 square root of 5 divided by 5, then cotangent theta will be 5 divided by 2 square root of 5. Alright, so after simplifying this, it will, for cotangent theta, we're gonna have square root of 5 over 2. Alright, so if you think that this example is interesting, so let me know by leaving a comment below. Also, if you found this video helpful, don't forget to like, subscribe, and hit the bell icon so you never miss a math adventure. Once again, this is Mr. H, and thank you very much for watching, and I'll see you in the next video.